The turn of a metal faucet, a clear, cold stream hits the ceramic sink. This is a basic, unremarkable reflex of modern civilization, a symbol of absolute control over daily life. But this water's a physical anomaly.
It flows against gravity, ignores natural geography, and violates the laws of thermodynamics.
The drying up beds of once mighty rivers, asphalt highways bursting under the pressure of dozens of atmospheres, toxic sediments at the bottom of dead reservoirs. This continuous flow in the sink is not a natural phenomenon. It is the product of a trillion-dollar artificial circulatory system stretching millions of kilometers underground. By the end of this journey, the illusion of simple domestic convenience will vanish.
The true weight, scale, and critical vulnerability of the gigantic mechanism that prevents megacities from dying of thirst within 72 hours will be laid bare.
But to understand the workings of this life support machine, we must return to an era when water was unbearably heavy and human reach was minimal. Water possesses a merciless physical characteristic. It has a colossal mass. 1 cubic meter weighs exactly 1 ton. Historically, cities could only expand to the limits where this enormous weight could be carried by ordinary physical strength. Ancient people had to constantly carry water in heavy jugs and wineskins from rivers or wells. Human muscle power and the endurance of draft animals set a very strict limit on the size of any settlement. A city simply could not stray far from the shore of a freshwater body. As soon as the population exceeded the capacity of the porters, development came to a complete halt. Roman engineering attempted to elegantly circumvent this harsh limitation by creating the famous aqueducts. Ancient builders erected grandiose stone bridges along which water flowed directly into the centers of metropolises. Architects truly harnessed water to their needs for a long time. However, they remained hostages and slaves to gravity nonetheless.
The liquid could flow only from top to bottom, and this dictated its own strict rules.
Building such channels required incredible precision and enormous effort. Aqueducts demanded a perfect gradient of just a few centimeters per kilometer of the route. Because of this, cities were forced to spread out across lowlands and valleys. Settlements remained firmly tied to the natural topography of the surrounding terrain. This ancient system functioned flawlessly for centuries without interruption. It managed as long as the scale of human consumption remained within the limits of the natural flow of the rivers. With the onset of the turbulent Industrial Revolution, this fragile natural balance finally collapsed. In the 19th century, an unprecedented growth of industries and factories began. Huge metropolises like London, Paris, and New York began rapidly absorbing the rural population. People flocked to the capitals in search of work in the new factories. The density of urban development became simply incredible.
Millions of new city dwellers were concentrated in the tiny spaces of working-class neighborhoods.
The rivers that had once supplied these areas with clean water for centuries simply could not withstand such a sudden burden. Waste from chemical plants and slaughterhouses began to be dumped into them en masse. Natural drinking water sources very quickly turned into foul-smelling open sewers. In London, the Thames became so filthy that in the summer, it emitted an unbearable, suffocating stench. To solve this monumental problem, engineers finally had to overcome the laws of gravity. They had to make water flow upward and over vast distances. Cities desperately needed new, sturdy pipes. They had to withstand powerful internal pressure without accidents or ruptures. Powerful mechanisms were also needed to generate and constantly maintain this colossal pressure. But the technology of the time lagged far behind the engineers' ambitions. It offered only very fragile and unreliable materials for construction. At first, they even used ordinary tree trunks, simply drilled through. Lead was also used, as it was a convenient and malleable material. fired clay was also employed, but it cracked instantly at the slightest shift of heavy soil. Any major city of that time remained an incredibly fragile organism. Its survival depended every day on the strength of the underground utilities. The well-being of millions of people rested on the integrity of swollen wooden dowels. The life of the metropolis hung by a thread because of rusting cast-iron joints just a couple of meters underground. A single major accident could easily leave entire neighborhoods without drinking water. The end of the 19th century drastically changed the rules of the game. It demanded simply unprecedented volumes of clean water for the needs of cities. The growing heavy industry required enormous amounts of water to power its steam boilers. Thousands of gallons were needed every minute to cool red-hot machines and machinery.
Water flowed like a river to wash down dirty factory floors and workshops.
Industry became the primary consumer of this resource. To quench this growing industrial thirst, engineers began laying new pipelines. Pipes stretched farther and farther beyond the familiar city limits. It was then that the bold concept of creating gigantic artificial reservoirs emerged. To supply water to the expanding capitals, vast valleys were ruthlessly flooded. Dam builders wiped entire villages off the face of the earth and altered the natural courses of rivers. To at least somewhat protect the rigid cast iron from breaking, the system had to be made flexible. Lead was used extensively to ensure reliable pipe connections and flexibility at the joints. This heavy metal and dangerous neurotoxin became permanently woven into the hidden infrastructure of megacities. Lead was poured into the joints to prevent catastrophic ruptures of the main lines. This saved the fragile pipes during severe seasonal freezing and ground shifts. Stable pressure in this colossal underground network was maintained by giant steam engines. These were true steel monsters of the Victorian industrial era. The enormous, deafeningly roaring machines towered several stories high. Their rotating flywheels weighed tens of tons each.
These noisy pumps operated non-stop around the clock, pumping millions of gallons of water.
Because of these pumps, the city's water supply became inextricably tied to coal mining. The steam engines devoured coal by the trainload every day, without breaks or days off. A stoppage in the long coal trains meant the inevitable and rapid demise of the entire water system. City authorities were forced to create huge strategic fuel reserves near every station. The energy dependence of water systems became a harsh new reality of the industrial world. At the same time, the underground pipelines themselves were laid out in a surprisingly chaotic and haphazard manner. Builders worked without any unified master plans or a clear vision of the future. No one bothered with complex calculations or factoring in the massive future load. New, growing residential areas were simply hastily connected to existing old pipes. This inevitably led to constant drops in water pressure and endless accidents. All this complex and problematic infrastructure was quickly hidden beneath stone pavers and fresh asphalt. The authorities tried to bury the trenches as quickly as possible to restore the street's presentable appearance. Any evidence of the system's vulnerability was swept out of the citizens' sight. No one was supposed to see the hidden truth about the state of the underground utilities. The city survived only thanks to metal rusting in the mud and toxic lead. The late 19th century became a time of frantic expansion in urban development. Engineers were always playing catch-up, trying to provide water for the influx of migrants. This water system was not built to last forever or for future generations. It was built in an incredible rush solely to resolve the immediate crisis of the growing masses. The main goal was simply to prevent the metropolis from dying of thirst right now. The foundation of modern urban water supply was laid using materials doomed to inevitable decay in a corrosive environment. The mid-20th century was marked by the triumph of engineering over nature. The era of the Great Depression and the post-war boom gave rise to projects of monumental scale. At that time, governments were pouring colossal sums into construction projects that had previously seemed impossible. Humanity sincerely believed that it was now capable of completely reshaping the planet to suit its needs. The great era of reinforced concrete began. The famous Hoover Dam blocked the mighty Colorado River, creating a gigantic artificial reservoir right in the barren desert. This structure became a symbol of humanity's new power over the elements.
Water was definitively stopped, stored, and subjugated to the will of engineers.
California's massive aqueducts stretched for hundreds of kilometers across arid lands. They carried billions of cubic meters of this vital liquid over high mountains and dangerous tectonic faults. For the builders of that era, geography no longer mattered. Engineers had learned to reverse the flow of rivers and direct them to places where water had never been. The complex water distribution system was finally hidden deep underground. For the average city dweller, it became an invisible and familiar given. People stopped wondering where the water in their homes came from. A powerful and dangerous illusion of an endless and absolutely reliable resource took hold in society. The simple turn of a faucet now guaranteed a strong and steady flow at any time of day. Water began to seem frighteningly cheap and universally accessible to people. Because of this, perfectly manicured lawns began to sprout en masse even in the driest regions. In the scorching deserts of Arizona and Nevada, hundreds of golf courses suddenly appeared, requiring massive amounts of irrigation. From the outside, the underground infrastructure looked completely invulnerable and eternal. Main tunnels several meters in diameter were built from durable, reinforced concrete. To their contemporaries, they seemed like the reliable arteries of a new, progressive world.
These colossal structures were supposed to last for hundreds of years without any repairs.
In those years, almost no one thought about how exactly thousands of kilometers of pipes would need to be replaced in the future. These vital arteries ended up buried beneath a dense grid of heavy skyscrapers and shopping centers. Now, access to them is practically blocked by layers of concrete and private property several meters thick. Modern cities have become hostages to their own grandiose underground structures. The advent of the era of modern megacities radically altered the trajectory of the old gravitational conflict. Cities began to grow rapidly, not only outward, but also upward. New, super-tall skyscrapers required water to be delivered to unprecedented heights. Now, the resource had to be lifted 300, 400, or even 500 meters above ground level. Delivering tons of water to the 100th floor means overcoming colossal physical resistance. Normal city water pressure in pipes simply cannot lift a column of heavy liquid higher than a few floors. If too much pressure is applied from below, the old pipes in the basement will simply burst into pieces. Engineers had to find new ways to overcome gravity. This required the installation of powerful cascade pumping stations right inside the buildings themselves. Water in skyscrapers began to be pumped in stages, from one intermediate reservoir to another. On each mechanical floor, powerful mechanisms catch the flow and push it higher. This movement is driven by megawatt-class electric motors that consume enormous amounts of energy. At the same time, the world was experiencing explosive and uncontrolled growth in urban populations. Giants like Tokyo, New York, São Paulo, and Mexico City absorbed tens of millions of new residents. Water consumption in these parts of the world grew exponentially in a very short time. Every new house and every new apartment required its own connection to the main network. To deliver scarce water to the distant outskirts of the sprawling metropolitan areas, risks had to be taken. Water system operators had to radically increase the operating pressure in the old central pipelines. This was the only way to push the required volume of water through the endless underground labyrinths. But the city's networks were not designed for such extreme operating conditions. As a result, the entire urban infrastructure has turned into a dangerously taut string. Millions of tons of heavy liquid are forced through narrow and rapidly aging channels every day. The system is operating at the limits of its capacity, which were established decades ago. We continue to strain a mechanism that has long required a major overhaul. Our hidden network of utilities has practically no margin for error left. It is forced to serve a massive human population every second, a population for which it was never designed. The slightest glitch in this complex chain could lead to catastrophic consequences for the entire metropolis. The hidden network no longer had any margin for error. It was forced to serve a mass of people for whom it was never designed. The system began to devour itself. The high pressure required turned the tiniest defects in the old cast iron into destructive breaches. Every pressure surge strikes the worn-out walls with incredible force. The scale of hidden losses today boggles the minds of engineers and environmentalists worldwide. In some modern megacities, up to 40% of treated drinking water is lost on its way to the end user. Huge volumes of this priceless liquid, extracted with such difficulty, simply vanish into thin air. It flows ceaselessly into the damp earth through thousands of invisible cracks and broken joints. Because of these underground sinkholes, entire streets suddenly collapse into the ground with a deafening roar. Huge sinkholes mercilessly swallow parked cars, buses, and even sections of residential buildings. People are literally walking on a thin crust that hides deep water caves beneath it. The city's architecture is losing its footing due to invisible underground rivers. The process of destruction is taking place not only on the outside, but also within the infrastructure itself. From the inside, old water pipes are also steadily changing their original shape. Salts and minerals dissolved in water have been continuously settling on the metal walls for decades. This process continues unabated, layer by layer, building up a very hard stone crust. Experts call this process a veritable arteriosclerosis of the massive urban body. A pipe that once had a substantial diameter of a full meter changes catastrophically beyond recognition. It gradually turns into a narrow, dark channel with a cross-section of just a few centimeters. The rest of the interior space is tightly clogged with solid calcium deposits and spongy rust. This hard mineral buildup is sometimes impossible to break through even with the most modern cleaning equipment. Engineers are forced to completely cut out such irreparably damaged sections of the underground network. The diameter of the mains narrows inexorably, and their total flow capacity drops catastrophically with each passing year. The system is literally suffocating from the debris that has accumulated inside. Due to such aggressive loads, the sharply increased pressure simply ruptures the most weakened sections of the network. This rapidly creates a deadly and completely self-perpetuating cycle of physical infrastructure destruction. A single technical error by a dispatcher inevitably triggers a whole chain of new large-scale failures. The machine breaks down under the influence of the very parameters it is forced to maintain for its own operation. The system for monitoring these underground flows is also long outdated and has deteriorated significantly. Water supply gate valves, giant steel valves weighing tons, often fail. Due to constant underground dampness, they become firmly stuck together because of pervasive corrosion. The metal fuses together, turning the moving mechanism into a monolithic block. Such frantic excavation work is illusory and does absolutely nothing to solve the main technical problem. This is not the infrastructure modernization that officials so often like to talk about. It is a desperate attempt to patch holes in a worn-out, pressure-pulsing mechanism that cannot be stopped for even a second. The breaking point becomes evident when a climate breakdown compounds the system's wear and tear. Nature quickly ceases to forgive human engineering errors and years of negligence by city authorities. A striking historical example is the so-called Day Zero scenarios, which recently shocked the world. Such catastrophes have already become a reality in Cape Town, South Africa, and São Paulo, Brazil. The invisible urban life support system suddenly becomes frighteningly tangible for everyone. And this happens precisely because of its complete absence from the taps of millions of ordinary consumers. People who have grown accustomed to unlimited comfort over the years are, for the first time, beginning to seriously consider the value of every drop saved. Panic grows with every hour of interrupted water supply. But a real water crisis in a metropolis is far more than just a prolonged natural drought. It is also a sudden man-made collapse of the city's main underground water main. Imagine a single major rupture in a 70-inch pipe right in the heart of a densely populated business district. Such an accident instantly paralyzes life in entire vast residential areas. This aggressive force of nature destroys everything in its path, sweeping away parked cars and flooding basements. A moment arrives when pressure drops critically and sharply throughout the rest of the city's water supply network. From the taps of millions of bewildered residents, instead of the familiar, reassuring hum, there remains only a ringing, terrifying emptiness. It is then that every resident of the metropolis comes to fully understand the true, supreme value of water. Without it, the massive, gleaming glass skyscrapers become completely unsuitable for normal life. And this irreversible change does not take weeks, but occurs within just a few hours. Comfortable homes worth millions of dollars instantly turn into concrete cages. All available supplies of plain bottled water in nearby supermarkets vanish without a trace. Grocery store shelves are completely emptied within the very first hours of the crisis. A completely uncontrollable mass panic quickly breaks out in the city among the bewildered and frightened residents. Law and order begin to crumble along with the familiar level of civilized comfort. This spontaneous panic is inevitably followed by a complete transportation and logistics collapse on all major roads. A massive and desperate exodus of a huge population begins in search of new, safe sources of water. In these terrifying hours, the illusion of our absolute independence from the forces of nature shatters into pieces. It becomes crystal clear to the city's residents just how vulnerable their much-vaunted high-tech civilization really is. It becomes obvious that the metropolis is an entirely artificial environment. Its very existence depends entirely on the continuous rotation of the turbines at the pumping station. If they stop, the grand metropolis rapidly descends into the chaos of primitive survival. We have built gigantic architectural masterpieces, but a single weak link underground can destroy all this comfort. A minor technical glitch can easily escalate into a full-blown humanitarian catastrophe on a national scale. A malfunction in an old, rusty valve is capable of bringing an economy, one exceeding the budgets of entire nations, to its knees. Realizing the looming threat, city authorities and leading engineers finally initiate radical rescue projects. It becomes abundantly clear that this monumental problem can no longer be solved with temporary half measures. A completely new historical era of technological resuscitation of the old infrastructure begins. The planet's best minds throw all their available resources into saving the worn-out networks. Colossal budgets are allocated from the state treasury for these incredibly ambitious projects. Gigantic industrial seawater desalination plants are being built all over the world. These enormous, futuristic complexes are rapidly appearing on the coasts of the driest countries. Inside these buildings, seawater is forced through microscopic membranes under immense pressure. This cutting-edge technology is called reverse osmosis and requires equipment of the highest precision. The membranes trap every particle of salt, allowing only pure water molecules to pass through. Blind patching of leaks is being replaced by modern smart control and monitoring networks. Autonomous robotic probes are now regularly deployed inside dark and dirty pipelines. Highly sensitive acoustic sensors are also being installed en masse on the outside walls of old pipes. They are capable of listening for any suspicious grinding noise in real time, around the clock. The devices detect the slightest dangerous vibration of aging metal buried under tons of earth. This sophisticated acoustic system works much like a medical stethoscope on a patient's body. All collected information is instantly transmitted via wireless channels to centralized analytical centers. Artificial intelligence on powerful servers continuously analyzes these underground sounds and detects the slightest anomalies. The smart computer system learns on its own to predict impending pipeline ruptures in advance. It is capable of calculating metal fatigue long before the first drop appears on the surface. Dispatchers receive an alarm several days before a major accident reaches the road surface. This gives repair crews precious time to carefully replace the weakened section as a preventive measure. In addition to digital electronics, incredibly large-scale chemical intervention is actively employed. At water treatment plants, various additives are being artificially injected directly into the drinking water stream. Orthophosphates and chloramines are being used on a massive scale in very strictly calibrated proportions. This highly complex and expensive chemical mixture is designed to solve the long-standing problem of toxic compounds from the last century. City authorities are trying to save the population from the legacy of lead pipes. Additionally, entire arrays of powerful ultraviolet lamps and modern ozonizers are being installed at all treatment plants. They are vital for the 100% guaranteed destruction of pathogenic microorganisms. The fact is that many dangerous bacteria and viruses have, over time, become completely resistant to traditional, inexpensive chlorine. Engineers are forced to use intense light radiation and active gas to disinfect the water flow. Only in this way can millions of city residents be protected today from outbreaks of new deadly epidemics. Such large-scale intervention costs taxpayers hundreds of billions of dollars annually. This is a real heavy financial burden on the budget of absolutely any modern state. Essentially, we are witnessing a grandiose attempt to force a decrepit 19th century mechanism to function. Moreover, we want it to operate strictly according to the highest standards of the 21st century. This is an incredibly complex, expensive, and endless task that requires regular financial injections. However, such a global and costly rescue of the system inevitably gives rise to entirely new problems. Even more sophisticated and highly complex forms of vulnerability emerge in modern megacities. Every technological innovation introduced brings its own hidden threats. The system ceases to break down due to age, but begins to depend on a multitude of external and highly unstable factors. By saving the water supply from one crisis, we unwittingly lay the groundwork for another. In areas of constant discharge of such brine, vast and completely lifeless underwater wastelands form very quickly. Neither fish, nor algae, nor even the most resilient beneficial microorganisms can survive in these eerie dead zones. This creates a paradoxical and very sad situation for the entire ecosystem of our blue planet. A successful solution to a humanitarian problem on land inevitably creates a new, large-scale ecological disaster deep underwater. The delicate chemical balance in old pipes also harbors a hidden and very deadly threat. The process that prevents the dilapidated system from causing mass lead poisoning among the population turns out to be frighteningly fragile. All this protection depends entirely on the precise proportions of reagents added to the water. The slightest deviation in the formula at the water treatment plant is enough to trigger an irreversible chain reaction of destruction. Any tiny mistake by a tired operator, even a fraction of a percent in the water's acidity level, leads to disaster. This slightest chemical change instantly and mercilessly strips that very protective phosphate film from the pipe walls. The bare, toxic metal, dormant for decades, once again finds itself face to face with the flow of drinking water. Lead begins to dissolve rapidly and flow unimpeded straight into the taps of unsuspecting city residents. The world has already witnessed the horrific consequences of such engineering blunders in modern reality. As the infamous water crisis in the American city of Flint clearly demonstrated, the consequences can be truly catastrophic. A single wrong decision by dispatchers, made to save money, can throw a city back into the dark ages in a matter of days. This simple action can quietly poison an entire generation of local children with severe neurotoxins. A routine hacker intrusion into a poorly secured water utility dispatch system can cause a great deal of harm. Attackers can remotely and completely silently open the necessary electronic valves at the treatment plant. They are capable of deliberately dumping dirty, untreated sewage directly into the main drinking water reservoirs of the entire metropolis. And to do this, they wouldn't even have to physically infiltrate the secured perimeter of a critical industrial facility. This entire massive structure has become a very fragile balance of numerous independent factors. Every second, it balances between absolute stability of the power grid and the supply of necessary chemical reagents. Added to this is the constant headache of ensuring the digital security of control servers and databases. The failure of absolutely any of these critical links inevitably leads to an instant shutdown of the city's entire circulatory system. The modern water supply infrastructure of a metropolis is no longer just a collection of pipes and reservoirs. It is an extremely complex mechanical digital cyborg. Today, this hidden network has become a living organism made of metal and plastic. It breathes continuously and pulses heavily right beneath our feet. Within it, the raw physical force of water and the most delicate adjustments of a modern computer mind are inextricably intertwined. Human control over the elements began to seem absolutely limitless. Builders learned to raise entire artificial rivers to the 100th floors of glass skyscrapers. But this impressive power demands constant second-by-second validation. You can't just turn on the water and forget about it for decades. The city's water supply system has become incredibly sensitive to any external disturbances. The slightest drop in voltage in the power grid immediately triggers destructive water hammer in the underground mains. A massive volume of water, driven by inertia, slams into the worn-out walls with tremendous force. The pipes tremble deep underground, at risk of bursting at any inopportune moment. Changes in temperature within the storage tank also require an immediate adjustment of the dose of chloramine and other reagents. Nature constantly throws new chemical variables into this complex equation. Water utility specialists must react to the slightest changes faster than meteorologists. Water does not forgive even the slightest delay. This complex artificial system can no longer simply exist autonomously. It must be continuously and very actively maintained in working order through enormous daily efforts. Incredible financial budgets and human resources are spent on this. The system requires constant maintenance and vigilant monitoring by electronic systems. No major metropolis in the world is simply capable of shutting down its system all at once for a complete replacement of worn-out components. City authorities cannot shut down the main lifeline for an entire month for the sake of a peaceful overhaul. Repairs always take place exclusively on a living, pulsating body under pressure. Workers replace parts on the fly, risking a local flood. We have created an incredible, grandiose machine of survival that has become too complex for complete human control. No dispatcher can keep all the hidden connections of this network in their head. At the same time, it has become too critical to allow even a single mistake. We have become hostages to our own brilliant creation. This new fragility has nothing to do with the physical weakness of materials. The main danger lies in our digital system's absolute intolerance for any glitches. We have built a world in which comfort depends on every resource being stretched to the limit. There is no longer any room for pause. The turn of a metal faucet. A clear stream of water continues to flow into the sink. Outwardly, nothing has changed. But now, behind this simple action, one can clearly hear the hum of turbines, the crunch of cast iron settling beneath the asphalt, and the vibration of steel membranes at desalination plants. This is no longer a natural resource. It is a synthesized product forced through filters, enriched with corrosion inhibitors, and delivered against gravity at the cost of burning millions of kilowatts of energy. Humanity has subjugated water, learned to lift it to the heavens, and channel it through rocks. But the true price of this triumph is absolute, total dependence. Cities no longer stand on riverbanks. They hang on a thin, invisible thread that vibrates under pressure. And this life continues only until the pump stops somewhere deep underground.